In this session, we'll discuss utilizing the 2.5D toolpaths Intaglio and Prismatic as seen in some of the images. Essentially, these are V-carve toolpaths or relief toolpaths, depending on which toolpath we're discussing. So we can see that the cutter is varying the depth it is engaged into the material to control the width of the cut line. So in this case, we say that this is a 2.5D toolpath because not only is the cutter plunging on the Z-axis to control the depth into the material, it's also traveling on the XY axis to carve the contour. And as it reaches a narrowing area, the tool indexes up at an incline to give the final profile. So a standard 2D toolpath would be able to fill at a consistent depth, but not raise the cutter to allow for very thin strokes utilizing the same cutter just by varying the depth. And that's where the phrase 2.5D comes from in this. So what is required to work with 2.5D toolpaths Intaglio and Prismatic? Uh, to begin with, you will need the graphic level of Gravostyle. So we can see here that Gravostyle comes in several different levels. The graphic level is required. And as an option in the graphic level, you'll need the 2.5D toolpaths, which in addition to cutting and engraving, also gives you multi-tool sequencing, prismatic, and intaglio toolpaths. You'll also need some specialized cutters based on the line weight that you want to have in your carved letter. Also, you'll need to consider in the angles the thickness of material that you'll be using. So here are several cutters. This cutter, for instance, is a 120-degree angle. So the beveled tip is 120 degrees from side to side. And we can see the yellow contour basically represents the carve profile that a 120-degree cutter would have versus a 90-degree cutter, for instance. Okay. So here we can see essentially a 90-degree cutter. And for the 90-degree cutter, as opposed to the 120-degree cutter that's at the top in the center image, the 90-degree cutter would need to go essentially 2 to 3 times the depth in the material to reveal the same carve width that the 120-degree cutter could utilize. So the 120-degree cutter could, for instance, use a ½ inch thick piece of material and reveal a wide carved letter that maybe had a line weight of ½ inch or 3/4 of an inch. In order to get 3/4 of an inch line width with the 90-degree cutter, the cutter would have to go much deeper into that material and potentially could cut through, for instance, 1/2 inch thick material. So the consideration is how wide do you want your line widths to be and how thick is the material going to be that you are working in. And when we look at cutters and look at the different contours on the cutter, and we'll go through adding a cutter or modifying a cutter into the tool database, because many of the cutters that you use for this type work and other machining tasks aren't standard engraving cutters. They're going to be specialty cutters that are aftermarket cutters, and they will not appear in your standard tool database and will need to be entered. So for instance, when we look at this 120-degree cutter in the lower left, then the references that we have here, the 1¼ inch diameter is the width of the cut. So from the tip of this angled cutter edge all the way across to the edge of the other side of the cutter. So the total width or the reveal when this cutter plunges into the material to its full width is 1¼ inches. So that's the widest line that it can cut in a single stroke. The cutter depth would reference the 0.625, so the cutter depth being from the crown or the tip of the cutter back to the shoulder of the cutter. What is that depth that the cutter would sink into the material to give me that 1¼ inch wide reveal? a common error is that we look at the cutting depth of a cutter like this 120-degree cutter, and we would include the shoulder back here. And that's incorrect unless you want your letters to have a 90-degree angle around the edges before the 120-degree bevel begins. And that's typically not a desired appearance. Okay, so we measure from the widest part of the shoulder at the face of the cutter up to the tip, and that gives us our cutting depth. Okay. This cutter happens to reference that it's a 1/2 inch shank, so the diameter of the shaft of the cutter is 1/2 inch. Okay. Looking at a different profile, so this is a single flute upcut end mill, and this cutter has a diameter or width of cut that's the width of the tip from its widest side to its widest side. Okay, and then the length of cut for this cutter would be how tall is the spiral flute. In other words, how deep can I sink this cutter into the material in a single pass and still have exposed cutting flutes. So I do not consider the shaft of the cutter to be part of that length of cut. Okay, so if I sink the cutter into the material, plunge it down beyond the cutting flutes, then yes, I have cutting flutes that will drill into the material, but as that cutter starts to move laterally through the material, I only have cutting flutes here on the tip to remove it. So if I sunk it further in, there are no flutes up here to cut. So this is considered the shank, or the would be considered as part of the overall length. So the overall length of the cutter would be from the tip of the cutter all the way back to the end of the shaft. Okay, but the cutting length or length of cut is always going to be the height of the flutes. And in some cases, you'll see cutters that these flutes may extend further up, but you can see that the diameter of the flutes changes, and they're just for chip extraction at that point. If the diameter changes and the cutting edge doesn't continue up, then that would just be milled surfaces to help eject the chips, and not necessarily what you would be considering as part of the length of cut. Okay, and then down here are a few more terms that help to describe the cutter elements. Of course, the overall length being from tip to the butt end of the cutter. Cutting flutes would be the spiral flutes that rotate around the cutter to slice the chips and remove them. Cut diameter is the width at the tip of the cutter. Okay. So a few points that we will begin with that will help as we go further into the explanations. So now let's take a look at Gravostyle. So for the exercise that we're doing today, we're going to assume that our material piece is 20 inches by 20 inches. I'm putting a margin of 1/2 inch around the outer edge of the material. And I do want to tell the software, in this case, what the thickness is of the material. When we're doing 2D engraving, we're typically not filling in this bottom field for the thickness of material. But when we're doing 2.5D work or 3D work, we need to tell the software how thick the medium is so that it doesn't pierce the cutter all the way through your material without you intending to do that. Okay, so I have also checked that my margins are equal to left, so that whichever value I put in the first box is translated into the other three sides. So this gives us our material definition. Our cursor begins right in the center, so I'm going to go ahead and select the font style that I want to use, and I'll use Century for this, and let's make characters that are 2 inches tall. So we'll put some text on here. Okay, and I've intentionally left a line blank because in that line, I want to insert in a graphic element. So I'll go to my symbols library and come into my bars and perhaps select this bar, and then we'll just plug this in and visually place it and stretch it to the contour shape and position that I'd like to have. I can use my alignment tools with this contour highlighted if I wanted to position it exactly in the workpiece. In this case, I don't want to do that. I just want to optically position it. Okay, so I have the opportunity at this point, if my text isn't large enough, that I can select my text and go ahead and change the size of that text if I like. Okay, so we'll make that 2.5 inches and go back to selection, and then I'll reposition my decorative element just a little bit here. And I'll go ahead and make sure that that is left to right centered. Okay, so at this point, if I wanted to have a decorative border around this workpiece, then I could simply add that. And we'll say that I'll do a border with radius corners on it. Okay, so I'm going to go ahead and select the rectangle, drawing tool, start to click and drag, and when I get it in the proximity that I want, I'm going to press F2 and tell it that I would like for that to have radius corners and make those radius corners 0.35. I can also give exact coordinates for width, height, and position based on the selected element, but I'm just going to click OK, and then I'll drag this and position it where I want it. Okay. So I may want an additional contour that exactly matches that, so I can go to my special effects, and in special effects I can tell it to trace the element on the inside, and that I want this to be maybe 0.18 distance from the original. Keep the original, perfectly match the contour, and it gives me a second contour. So now I'll take these two contours and group them together because I want the software to respect those as one element when I'm calculating my tool paths. So I'll go ahead and select everything. Now I'm going to go into the CAM module and generate my tool paths for the Intaglio fills. Okay, so as I'm working with the software, at any point you can come up and click on the question mark, which will take you into the help menu. And in this case, the help menu for Intaglio. This is what basically by typing Intaglio in, I'm presented with a page of instructions. I can scroll down for further explanation. Also, anywhere that I see a color, a green element of text, I can click on that and it will take me to further explanation on that point. So it is a live database and it will select through and give you additional information as you click on the hypertext links. And we can see that there are several different elements in here with instruction on Intaglio. But I wanted to point this out. You can print these instructions as well, but this is a very useful tool. It's available throughout Gravostyle. Okay. So let's go ahead and click on Intaglio. Ask me to save my document so that it can save the tool paths with that document. So we'll call this Intaglio. Okay, so I'm then faced with the interface to create my tool paths. Within this, the first thing that I will need to do is select the cutter that I'm going to use. So if I come into my tool database, I can come down and select the cutter. In this case, I'm going to use my 120-degree V-shaped carving tool. And this has a 1¼ inch diameter head. And I've set this up for high density urethane. Okay, so you have the opportunity when you're creating new tools to name them. For instance, I may have this V-carve shaping tool in the database several times, one with feed rates and piercing rates or plunge rates that are appropriate for high density urethane, another that has feed rates that's appropriate for MDF, maybe yet another that has feed rates as appropriate for carving acrylic or other woods, harder woods. So in all of your tools, as you're setting up specialty tools for doing advanced tool paths, consider that you may set that same tool up several times just with different feed rates based on the material that you're going to use that tool in. For instance, I can tolerate a very, very, very much more aggressive feed rate if I'm doing high density urethane as opposed to milling aluminum. Okay, so to come in and set up a new tool, I would simply go and right click on the folder that I desired to have that in and click Add Tool. Okay, so in this case, I'm going to go ahead and set up a new tool, and we'll say that this is going to be my V-carve, 120 degree, 1.25 diameter, and this one I'll make for MDF. Okay. So the first thing that I will do is select the contour of the cutter. So this cutter will have a sharp tip. There are other selections for a rounded tip, like a ball nose end mill. This one would be, for instance, for a 90-degree end mill. Others for drill bits, etc. So you have the ability to pick the profile that best suits your cutter. So here, the reference appears to be the diameter of the shaft of the cutter or the cutter shank, but indeed, really what we want to enter into this field is the width of the cut. So the width of that cutting head, and in this case, it was 1.25 inches. Here, I'm putting in the angle of cut. Very important note here. So this diagram is showing me that I need to put in half of the included angle. So if I have a 120-degree cutter, I wouldn't put 120 degrees here because 120 degrees is the included both angles. I simply would put 60 degrees here because it's asking me what's the angle of half of the cutter tip. So if I do put 120 degrees here, then you'll notice this window over to the left is showing me the profile of my cutter. And it gives me an error, first of all. But what it also would do is it would square off the tip of this, showing me that the tip of the cutter is not at the 120-degree angle. So the next step is to put in the tip width of the cutter, and this particular cutter comes to almost a perfect point, so I'm going to tell it that it's a 5/1000th tip width on that. Okay, you have the opportunity to add a supplier notation in or a part number for this cutter so that when you need to source them, you know where to go and cut and source those. Then we're going to fill in feed rates. So it's always best to start with lower feed rates. And as you're working with your material and figuring out what speed the material and cutter will tolerate with and still give a clean cut, you can come in and increase these values. But in the machining module, the tool setup is going to dictate the feed rates. So here I might start with a 0.5 and have the cutter max out at 1.2 feed rate. For the flying angle, I want to tell this that the angle is 60 degrees. So basically, the descending angle is as that cutter is entering into the material, what is the angle of half of the tip of the cutter? So that as it's feeding that cutter into the material and indexing it on the XY, it knows what slope angle to set up so that the profile revealed in the edges of the carving are appropriate. Okay, and then here is the plunge rate. So how fast can I plunge this cutter down into the material? How fast can it drill straight down into the material? This is an important setting because if you have too aggressive a plunge rate set, you could impact the cutter onto the material so quickly, especially with metals like aluminum, stainless steel particularly, or tool steel, you could impact the cutter so quickly into the metal that the cutter can't remove the metal and cut its path down into the metal. And what would happen is something would have to give. If it impacts and feeds so fast that the cutter can't remove the material to clear its path, then it's going to fracture the tip of the cutter, or it's going to hang on the material and move your material or stall the machine. So important to match your plunge rate, and there's a bit of trial and error. Again, start slow and then increase this until you find a feed rate that's comfortable. And typically your ears will tell you when the machine's struggling, or the quality of the cut will tell you when the machine's struggling and you're feeding it too fast. Okay. And then the next is this rotation speed of the cutter. This only really applies to the milling machine that has the automatic tool changer, but oftentimes I'll put in here a reference to tell me that I typically want to rotate this cutter at about 18,000 RPMs. Okay. And then the cutting depth. And this goes back to what is the cutting depth, or the flute area of the cutter. How deep can I pierce that cutter in one plunge? How thick a slice of material can I cut away? So in this case, this cutter had a 0.625 cutting depth. Okay. So, and what I'm telling the cutter is, if you need to go deeper than 0.625 into the material, then you need to make multiple tool paths to do that. Okay, and we'll come back to that a bit later. So we'll select this, and we can see that I've created a new tool in my tool database. So I'll click check mark, and here I'll come and select that tool so that it makes my calculations based on that tool. So in this screen, it's basically asking me, how deep can I allow the cutter to carve into the material? And in this case, you would not want this depth to be more than about half to 2/3 the thickness of your material. Okay, so I have 1-inch material, so I might tell this that it can go 3/4 of an inch as the maximum depth into the material. And then a number of steps, basically it's saying to go that depth into the material, it should make 5 steps. In this case, we probably can make that in actually 2 steps. Okay. Next is the type of milling that we're going to do. So standard or optimized. Typically we'll just select optimized here. Now there are some more advanced selections that you can make as you need to have more control. So here we have a standard and an expert mode. Standard mode is what most people will use. So basic entries here that allow you to control max angles and whether it's doing multiple passes pocket by pocket or global, meaning if the cutter has to make 2 swipes in an area to clean it out, does it make the 2 swipes at one time on that letter and then move to the next letter, or does it go through the entire sign making 1 swipe and then comes back globally and makes a second pass to give the second layer of depth? Okay. And then on the expert mode, we open up additional fields that we can select the contours, whether it does inside contours, then outside contours, or whether we're optimizing, etc. So some additional controls that you have here, and these will vary a bit based on the tool path that you're working with. So for now, we're just going to go back to the standard settings and go to general and click the check mark. So now I can see that I have a new color contour that's appeared on my workspace, and I have a new tool path that's appeared. So tool path 000 is the carving tool path that was just generated. So important note here, if you do not see the toolpath list, then you will come up to this icon to activate the toolpath list. So most of these menus can be turned on and off as well. This menu is to create toolpaths. So if you come to this page and you don't get your list of toolpaths here, then this would be the icon. Also, I can click on my tool database and open up my database of tools so I can add a tool, edit a tool, etc. right from this screen. So that's something that can be handy to access as well. Okay, so now I've created my toolpath. I can see my toolpaths are available in a different color. So this is where I would send this to the rotary engraver. So if I right click on Intaglio toolpath and come down to machining, then my machining window will open up, and this is where I would actually send the job over to the engraving machine. Okay, I don't have an engraver attached to my software, so it's not going to allow me to go any further, but we can see here that it's expecting my material to be placed in the upper left corner of the table. If I needed to relocate that, then I could come down and put coordinates of where I was going to locate my material on the table. But in this case, we'll leave it in the upper left corner. I'm not reversing the image as if I were doing the carving on the back side of a piece of acrylic instead of the face. Also down here, I'm using the spindle with normal engraving. I could send over test inscriptions so that it did rendering in the air over the material of where the lettering would go, for example. I do want to pay attention to my lift, and this is how high the cutter lifts out of the material when it goes from contour to contour. Typically 0.2 inches is a good starting point. As you become more comfortable with your machine, you may reduce this down to 0.08 or 0.1. Basically, the greater the number, the higher the cutter comes out of the material and then has to travel back down. So it does add a slight amount of time to your engraving cycle. Okay. All my feed rates are set automatically by the software. If for some reason I needed to come in and override some of those, I can simply unlock, and now I have access to change feed rates from this page. And then I click run to send the job over to the engraver. I also can preview the job here to see exactly where it's going to appear on my engraving table. Okay. So as well, I can zoom in to see exactly what the toolpath is going to look like. All right, so this is to send it over to the engraver. Now, before sending it over to the engraver, I always recommend that you go in and take a look at the engraving job in one of the simulations. So we have two different simulations. We have the first one is just standard simulation. So it's going to give me a quick rendering of what the finished sign is going to look like. If in this view, my tool paths don't appear to be clean, then it is not going to render and give me a clean image. So for instance, if these cross lines were washed out in this image, they're likely going to be that way on my finished product. So go back and revisit your tool paths, make changes to the depths, make sure you have the right angles set for your cutter in the tool library before you proceed and waste material, essentially. So I mentioned that there was also another simulation, and that is the NC simulation. So if I click on NC simulation, then this just gives me a little different view, and I hit play, and it shows the material being carved. It shows me exactly what's going to be my finished product. Okay, I have the opportunity also to come in and zoom and draw a box in an area and hit play again, and it will re-render. And this is exactly what the details should look like on my carving. The only reason that the details shouldn't come out looking very, very similar is if you've set your Z inappropriately. So if you don't set your Z to the surface of the material, maybe you set the Z a little above the material, or when you're setting your Z, your cutter pushes into the material, and that's a common thing with foam if you're not careful, then the depth of the cutter would be different than in the rendering. Okay, so one way to troubleshoot that. There also is an additional somewhat hidden simulation. So if I go to NC simulation and I hold shift when I click on NC simulation, then it's going to open a different simulation window. And this one's interesting because here I can control the speed that the simulated cutter is making on the screen. So if I slow this down a little bit and go ahead and hit play, then I can see basically a slower rendering of the carving, and this rendering is going to go in exactly the same sequence that my carving would. Okay, so that allows me to speed it up, slow it down. I can also look at things like the theoretical tool paths, so the outside of where the tool's going to go. I can look at a wireframe view of where the tool's going to pass. I can look at the travel above the material. So this is the path that the tool is going to travel in when it's above the material and not cutting. Okay. I also can look at the clipping, and basically what the clipping does is as I slide the clipping, I can see some white areas appear. So the white areas that appear first, like in the design in the center, those are the deepest carvings in the material. So in order to get the line weight to show the width here, it sank the cutter deeper in. So this will give me an idea of what areas are going to be carved deeper, wider lines, versus what areas will be more petite carvings, like the thin contours of the Y. Okay, so another point to mention is that when we're doing Intaglio and Prismatic, we're always going to be using a true type font or closed contours. So we would not be able to generate these tool paths if we were using traditional engraving fonts that are 1, 2, or 3 stroke fonts. This does require that you have closed contours in order for the CAM module to calculate these tool paths. Okay, so at this point, this job is ready to send to the engraver. So we'd right click, go to machining, and simply click run. Okay. So the prismatic tool paths work very similar to the Intaglio tool paths. So you can go to the instruction manual. You can also play with the prismatic a bit. So one important thing that I do want to mention is here, if I made a mistake when I calculated this tool path, maybe I didn't select the right cutter, or some parameter wasn't correct. In order to get rid of this tool path, I simply right click on it and delete it. Okay, so that removes it. So now I can take my same image and go over and select Prismatic. I can select the cutter that I want to use. And select whether I want to do a carving into the material or have a relief. Okay. Give it parameters such as the maximum depth that I'm going to allow. Again, I'll put in 0.75. Typically, you're going to use conventional milling. There are some instances where we would use climb milling, but that's more for cutting out shapes as opposed to doing carvings or reliefs. And we'll click check mark. Take the software a few seconds, and it will go in and render our tool paths for the prismatic sign. Okay. So there are several variations that you can do based on how you group your inner contours versus an outer contour. So if I wanted to carve away the surface of the sign and leave these letters raised, I would need to have a single line outside, and then group that together with the contours in the center so that it knew to carve from the outside and leave the letters behind in the center. Okay, so here we can go and have a look at our NC simulation and see the carvings here as well. Okay. I hope this session has helped to address some of the questions that you have. Feel free to contact our technical support department with any additional questions at 800-843-7637 and press 4 for tech support and follow the recorded prompts.